Welcome friends to a new session on mathematical modeling. Political models part 2. Let us continue with our discussion on models from political science. Comparison voting. Let us begin the session with a brief discussion on 4 different election rules. Plurality election, in which the voters cast their vote for one candidate and the candidate with the most number of votes win the election. Runoff election, which is between top 2 vote getters in plurality election if no candidate receives a majority. Here also the voter casts his vote for one. Negative voting election, where a voter vote for one, that is +1, or against one, that is -1, but not both. Approval voting, in which negative voting is not allowed, but a voter can cast a single positive vote for as many candidates as he wishes. In other words, he can vote for between 1 and 5 candidates. He does so by writing on his ballot the name of all candidates he chooses to support. There is no runoff election. It has been proposed by George A.W. Baum that voters in an election be allowed either to cast a vote or a vote against one candidate, but not both. Under this scheme, a candidate's negative votes would be subtracted from his positive votes to determine his net vote, and the candidate with the highest net vote would win. Baum argues that the introduction of negative votes in United States presidential elections would force the candidates to appeal to the voters with positive programs, not just try to be the least unpopular candidate in the race. To prevent a candidate from winning who had little popular appeal, but who otherwise might be preferred because he attracted few negative votes, Baum suggested that a threshold be set that a winning candidate's net vote would have to exceed for him to be elected. In this session, we will see that there is never any incentive for a voter to cast a negative vote in a 2-candidate race except to register his dissatisfaction with one of the candidates or possibly prevent the leading candidate from obtaining the number of net votes required to be elected. Because a voter can always bring about the same outcome with a positive vote as with a negative vote in a 2-candidate race without a minimum threshold, negative votes are superfluous in such a contest. To be sure, the psychological impact of negative votes may be considerable, especially in the case where the net vote of the winner is negative. However, if one's reason for casting negative votes is to ensure or prevent the election of a candidate, then a negative vote against a candidate always has the same effect on the outcome as a positive vote for the other candidate if there is no minimum threshold. In 3-candidate race, by contrast, negative votes may be uniquely advantageous. A voter can definitely do better in some circumstances by casting a negative vote against a candidate rather than a positive vote for either of the other 2 candidates. This fact will be demonstrated both in the case in which there is a runoff election between the top 2 vote getters in the plurality contest if no candidate wins a majority of votes. In races with more than 3 candidates, we will see that some of the advantages of negative voting break down, and it is useful to ask whether the idea of negative voting can be incorporated in a voting scheme that allows for the fuller expression of voter preferences. Negative voting in 2-candidate contests. Let us first examine the effect of negative voting in a 2-candidate contest. Assume that X and Y are the 2 candidates running for office, and every voter has a preference scale defined over these candidates. He may prefer X to Y, which we indicate by the scale XY, Y to X, which we indicate by the scale YX, or be indifferent between the 2 candidates, which we indicate by the scale X minus Y. Given negative voting, every voter has 4 strategies. First one, vote for X, that we will call as X. Second one, vote against X, that is X bar. Third one, vote for Y, we call it as Y, and vote against Y, we call it as Y bar. A voter is rational if he chooses a strategy that is undominated. There is no other strategy that is as good in all contingencies and in at least one contingency better. Contingencies are the states of nature that can arise from the voting of all the other voters. If there are n voters, there are 4 raised to n minus 1 states of nature, since the n minus 1 other voters can each choose one of their 4 possible strategies. However, many of these states of nature leads to the same result, which we define to be the ordered pair small x y, where small x is the net vote cast for x and small y is the net vote cast for y by the n minus 1 other voters. In fact, to determine the undominated strategies of a voter, we have to concern ourselves with only relatively few results, those in which the vote of a single voter can make a difference in the outcome. A voter's vote can make a difference if and only if it makes or breaks a tie. In a 2-candidate race, a voter can break a tie of the n minus 1 other voters if the result is x is equal to y minus 1 or y is equal to x minus 1. For all other results, a voter's vote could not change the outcome, which we define to be the candidate or candidates in the case of a tie, who receives the larger net vote and is thereby elected. If there is a tie, presumably one candidate will eventually be selected, perhaps by some random device. In evaluating this outcome, we assume that a voter allows for a possibility that either candidate will eventually be selected. Thus, if his preference scale is x y, it follows that he will rank the tied outcome x by y in the middle, x by y. If his preference scale is x minus y, then x minus x by y minus y, since indifference between x and y implies indifference among x by y and y. Let us see table 1. It gives the outcomes in 2-candidate contest with negative voting. We have seen that in 2-candidate contests, there are only 3 results of voting by the n minus 1 other voters in which a voter's vote is decisive, that is x equal to y, x equal to y minus 1 and y equal to x minus 1. Since the strategy a voter chooses cannot change the outcome associated with any other result, these are the only results relevant to the determination of undominated strategies. The outcomes generated by a voter's 4 strategies for these result in a 2-candidate contest are shown in table 1. Notice that the outcomes associated with strategy x bar are exactly the same as those associated with strategy y, and the outcomes associated with strategy y bar are exactly the same as those associated with strategy x for all relevant results. Since a voter who casts a negative vote against one candidate can always do as well by casting a positive vote for the other candidate, both these strategies are undominated and a negative vote is not uniquely advantageous in a 2-candidate contest. In the next section, we will show that in a 3-candidate contest among x, y and z, there is one situation in a plurality election in which casting a negative vote is definitely preferable to casting a positive vote. Even when the plurality election is followed by a runoff election between the top 2 vote getters, negative voting may still be advantageous. First, we will see the case without runoff. Negative voting in 3-candidate contests without a runoff. Consider 3-candidate contests in which the candidate with the most vote wins in the plurality elections. If there is no single plurality winner, a voter evaluates tied outcomes in the manner described in the previous section. In table 2, outcomes associated with 16 relevant results and 6 strategies of each voter are shown for a plurality election. Numerical examples are also given in table 2 for the subsets of relevant results that are the same except for the order in which x, y and z are listed in the triple x, y, z. Thus, for example, there are 3 relevant results in which 2 candidates are tied with the same number of votes and the third candidate has one more vote than the other 2. These results are indicated in the first 3 columns of table 2. Z has extra vote in column 1, y in column 2 and x in column 3. The numerical example given above these 3 columns in table 2, that is xyz is equal to 0, 0, 1, illustrates the case in which z has the extra vote. In table 3, the undominated strategies of a voter are given for 4 different preference scales. The 4 preference scales given in table 3 include all preference scales indistinguishable except for order. Thus, while the 3 outcomes x, y and z can be permuted in 6 different ways, the 5 permutations different from x, y, z are indistinguishable except for order. Similarly, there are 2 preference scales indistinguishable from x, y minus z except for order. Either y or z is ranked first, and 2 indistinguishable from the ordered pair x minus y z except for order. Either x or y is ranked last. If the order in which indifference is indicated is irrelevant, indifference among these 3 columns is obviously given by one scale, that is x minus y minus z. In the subsequent analysis, we assume that the preference relation P and indifference relation I that underlie the scales of individual voters are transitive. That is, if A, B and C are any 3 candidates, APB and BPC imply APC and AIB and BIC imply AIC. This assumption ensures that for a voter with preference scale XYZ or x minus y minus z, for example, it is always true that the pair XZ in the case of the former, x minus z in the case of the latter. For 2 of the 4 preference scales in table 3, x y minus z and x minus y z, there is only one undominated strategy of a voter. A unique undominated strategy is necessarily dominant, as good as, and in at least one contingency better than any other strategy, which means it is an unequivocally better choice whatever result shown in table 2 occurs. We will verify this for a voter with preference scale x y minus z. To do so, we must compare the outcomes associated with his dominant strategy x with the outcomes associated with his 5 other strategies for the 16 relevant results. To begin with, note that the outcomes associated with strategy x are at least as good as the outcomes associated with his 5 other strategies. Thus, for example, if strategy x does not yield his first choice x as an outcome, neither do his other strategies. Is strategy x better than every other strategy in at least one contingency? For result 5, it yields x, which is a better outcome for our voter than strategies x bar, y, y bar and z, which all can lead to non-preferred outcomes y or z offer. But strategy x is also better than strategy z bar, because even though it leads to the same outcome as x for relevant result 5, x leads to a better outcome than z bar for relevant result 6, that is x by y by z versus y. In this contingency, strategy x allows for the possibility that outcome x will be chosen, but strategy z always ensures that non-preferred outcome y will be chosen. Thus, we have shown that x is a dominant strategy for a voter with preference scale x, y minus z, and it leads to outcomes at least as good as and sometimes better than any other strategy. The fact that z bar is dominant when the preference scale of a voter is x minus y, z demonstrates that a negative vote is uniquely advantageous in this situation. While it leads to no better an outcome than strategy x or strategy y for 13 or 16 relevant results, it yields to a definitely superior outcome for 3 results, better than x for results 6, 9 and 15, better than y for results 5, 8 and 14. We say that z bar dominates x and y as well as all other strategies for a voter with preference scale x minus y, z. The preference scale x minus y, z of a voter says that he is indifferent between 2 candidates x and y, but definitely prefers them to the third candidate z. In such a situation, it is always rational for a voter to cast a negative vote against Z rather than a positive vote for either of the two candidates X and Y that he prefers. Negative voting in 3 candidate contests with a runoff. For the purpose of comparing negative voting in a single plurality contest with voting in a plurality contest followed by a runoff, assume that a voter cannot cast a negative vote in the plurality contest. Then the undominated or dominant strategies for the 4 preference scales given in table 3 are shown in table 4. Comparing undominated and dominant strategies in the 2 tables, we see that when a voter's strategy of voting against his last choice Z bar is unavailable, it may be advantageous for him to vote for his second choice Y if his preference scale is X, Y, Z, or either one of his choice X or Y if his preference scale is X minus Y, Z. If we assume that the runoff occurs if and only if no candidate in the plurality election receives a majority of votes, the answer is not necessarily. That is, the restriction of voters to a single positive vote may again force them to choose inferior strategies compared with strategies available under negative voting even when a runoff is permitted. Let us consider an example. Assume that there are 5 voters whose preference scales are first one X, Y minus Z, second one X, Y minus Z, third one Y, X minus Z, fourth one Y, X minus Z, and fifth one X, Y, Z. From table 4, we know that voters 1, 2 and 3, 4 have dominant strategies, that is vote for X and vote for Y respectively. Now, if voters are restricted to a single positive vote in a plurality election, voter 5 has 2 undominated strategies, vote for X and vote for Y. Clearly, strategy X would be preferable if X and Y were tied and Z were out of the running, and strategy Y would be preferable if Y and Z were tied and X were out of running. Regardless of which undominated strategy voter 5 chooses, either X or Y will receive a majority of votes and there will be no runoff. If voter 5 chooses Y and Y thereby obtains a majority of votes, 3 of the 5 voters, that is 1, 2 and 5, will be dissatisfied. For X is the so called Condorcet winner, that is the candidate preferred by a majority of voters in pairwise contest between each of the other candidates Y and Z. In a pairwise contest between X and Y, X would be preferred by voters 1, 2 and 5. Similarly, these voters would also prefer X to Z in a pairwise contest between those two candidates. Yet, if all voters except voter 5 choose their dominant strategies and voter 5 chooses his undominated strategy Y, Y will defeat the Condorcet winner X. The negative voting would have prevented the choice of Y in a plurality election with a runoff if there is no majority winner, because whichever of his undominated strategies voter 5 chose in the plurality election, X or Z bar, he would have prevented the election of Y. If he had voted for X, X would have defeated Y 3 votes to 2 and there would have been no runoff. If he had voted against Z, the plurality contest would then have resulted in a 2 to 2 tie between X and Y, and X would have won in the runoff since voter 5 would prefer him to Y. Clearly, allowing for a runoff in a plurality contest restricted to positive voting does not necessarily recapture the advantages of negative voting and lead to the election of the Condorcet winner. Permitting negative voting does lead to the election of the Condorcet winner if there is a runoff between the top 2 vote getters when neither finalist receives a majority of votes. Now, before concluding, let us summarize what we have learned in this session. We started our discussion with a brief introduction on different election rules. Then we discussed in detail the negative voting in 2 candidate contests and negative voting in 3 candidate contests with and without a runoff. We have seen that Although negative voting offers no unique advantage in two candidate contests, negative votes in a plurality contest among three candidates with or without runoff between the top two may be uniquely advantageous for a voter depending on his preference scale. In addition, a negative voting can ensure the selection of a Condorcet winner when a runoff does not. For further understanding of the topic, try out these exercise problems. First one, try to explain similarities or differences in the election results under the 4 different election rules. Second one, which of the 4 rules seems fairest? Specify criteria. Third one, is there an election rule that you would prefer to any of the 4 that does not require voters either to rank the candidates or to allocate different numbers of votes among them? Why? Fourth one, try to explain why a knowledge of the secret ballot election results does or does not change the outcome in each of the 4 election rules. Now, here are some references for further reading. First one, Modules in Applied Mathematics Volume 2, Political and Related Models by Stephen J. Brams, William F. Lucas, Philip D. Straffin Jr., Springer-Verlag 1983. Second one, Cumulative Voting, an Effective Electoral Device in Illinois Politics, Studies in Social Sciences, University of Illinois Press 1960. Third one, Game Theory and Cumulative Voting for Corporate Directors by Glasser, Gerald J., Management Sciences 1959. Fourth one, Paradoxes in Politics, an Introduction to the Non-Obvious in Political Science by Brams and Stephen J., Free Press, New York 1976. Fifth one, When is it advantageous to cast a negative vote by Brams and Stephen J., Lecture Notes in Economics and Mathematical Systems, Springer-Verlag 1977. With this, we come to an end of this session. We will continue with the advantages of approval voting in the next session. Till then, goodbye.